No, it's 25.5. I'm going to go slow, guys. I'm going to go slow. So let's do some application problems. Let's see what's up with these things. So I have a table, and it says the table to the right shows the velocity readings of a car taken every 30 seconds over a 5-minute interval. Okay, 5 minutes is 300 seconds. What is the approximate distance in miles traveled by the car during this 5-minute interval using MRAM with 60-second subintervals? Okay, we're finding area under this curve, but I want you to recognize the units, miles per hour and seconds. So when we find the area under this curve, it's not going to be miles per hour, or it's not going to be miles, because you're doing miles per hour times seconds. You got to translate that seconds into hours. And then you have miles per hour times hours, and they'll be miles. Do you guys know what I'm talking about? Okay. All right. So here we go. We're using MRAM, and they're telling us to use 60-second subintervals. So here's my first rectangle. From 0 to 60, rectangle 1. From 60 to 120, rectangle 2. 120 to 180, rectangle 3. 180 to 240, rectangle 4. And then 240 to 300, rectangle 5. Are we still okay? All right, we're using MRAM, width times height. I want all my units to be the same though. So before I even start, I'm going to turn those seconds into hours. So I know that each interval is 60 seconds. So before I even start, I'm going to go 60 seconds. And I don't know if you want to do a T or whatever. In 1 hour, there is 3,600 seconds. If you didn't know that, relax. You can go 1 hour, 60 minutes, and 1 minute, 60 seconds. You would have gotten the same thing. 60 times 60 is 3,600. Are we okay? Notice this will give you hours. So 60 divided by 3,600. I take my calculator. 60 divided by... Damn, man, I can't type for crap. 60 divided by... I didn't say anything bad, did I? So that is how many hours I have. Retraction is just 1/60th. Oh, Dutch. All right. 1/60th of an hour. There's 1 minute. In 60 seconds, that's 1 minute. 1 minute, 60 minutes. Okay. Cool or not cool? All right. All I'm doing is width times height, width times height, width times height. All of these rectangles have a width of 1/60th. Are we cool? The height is determined by MRAM. Do I use the 60? Do I use the 55? Or do I use the 50? Yes. Why the 55? It's the middle one. It's the one at 30 seconds. You're using the middle one. Does that make sense? So here we go. I'm going to write 1/60th times 55 plus 1/60th times, what's the next one I'm going to use? 45 plus 1/60th times, what's the next one I'm going to use? 45 plus 1/60th times 60 plus 1/60th times, which one? 40. Can you factor out the 1/60th? Yes. So here I am. So I'm gonna factor it out. So I'm gonna use the little fraction feature here. Alpha y equals enter 1/60, and I'm gonna put a parenthesis, and then I'm just gonna put all these values. 55, 45, 45, 60, 40. Let's see if I can remember. 55, nope, I already forgot. Short-term memory. What was the next one? 45. 45, and then was it 60, 60? 45. Oh, 45 again. 60 and what? 40. 40. Close it. I got 49/12, which is 4.083. That is distance. What are my units? No. Miles. Remember what you're doing. It's a rectangle. You're doing length times width. Miles per hour times hours. The hours cancels out and it's just miles. Are we cool or are we not cool? Okay, cool. All right. Hopefully this one is a really good example. So let's say you're an engineer or let's say you're a reporter And this is what you have. Let's make you an engineer, because engineers are cool. Well, I'm not saying reporting is not cool, but all right. Oil leaking out of a tanker damaged at sea. The damage to the tanker is worsening as evidenced by the increased leakage each hour. So this is a rate in gallons per hour at a certain moment in time, recorded in the table below. So in hour 0, we're leaking at 50 gallons per hour. And I don't know, maybe you have a sensor and it tells you the flow rate. At hour 1, it was 70 gallons. And notice gallons per hour. Notice that the rate is going higher and higher. It's increasing. The rate is increasing in gallons per hour. Give an upper and lower estimate of the total quantity of oil that has escaped after 5 hours. Okay, you guys ready? So after 5 hours, we're only going up to here. Give an upper and lower the total quantity of oil that escaped after 5. No, do they want after 5 hours? No. You know what? I think when I typed this out, I think I typed it out that has escaped during the first 5 hours.
Yeah, like after the 5 hours has been completed.
Yeah, during the first 5 hours. There won't be any ambiguity on the AP exam. It'll be very, very specific. Give an upper and lower estimate of the total quantity of oil that has escaped during the first 5 hours. Okay, there you go. I changed it. Ready, guys? Mm-hmm. So let's do the LRAM first. So if you need a visual, which you might, because some of you guys are visual learners. Yes.
Why didn't LRAM?
I'm going to do both, LRAM and RRAM, because in this case, it's a strictly increasing function. LRAM will give me lower, and RRAM will give me upper. Yeah. That's why I was about to. Yeah. So 0, 50. So look. 0, 170, 70, 297. I'm just doing like, and it's not perfect. 3. And I should have started way. That's fine. 5. It's not perfect. I just did some random. So if this were a curve, I don't know. Maybe this curve looks like this. Cool or not cool? It's not. Look, notice I didn't even label the y-axis. This is in hours, and this is in gallons per hour. And I just labeled it randomly, guys. I just made an increasing. Why am I doing LRAM? Why am I doing RRAM? Because if I do LRAM, so look, I'm gonna choose sky blue for. No, I'm gonna choose purple for LRAM. If I do LRAM, this is a under or lower approximation. If I do RRAM, I'm going to do it with burnt orange. If I do RRAM, yeah, if you have colors, this is a good one to do it with colors. If you have RRAM, that would be a what? An upper or an over. In this case, it's the same. Upper, RRAM, and upper because it's an increasing function. So an increasing function, LRAM and lower is the same, and upper and RRAM are the same for an increasing function. Cool or not cool? All right, I'm gonna keep my colors. So here we go. I'm gonna go lower or LRAM. My lower approximation. Here we go with the same color. All of them have a width of 1 hour. All rectangles there. So 1. And then the height of my first rectangle is 50 gallons per hour. Are we okay? Mm-hmm. Plus 1 times 70 plus 1 times 97 plus 1 times 136 plus, and is that the last one? Yep. What are my units? Gallons. Look, gallons per hour times hours. The hours cancel out, and you just get gallons. Do you guys see that? Yep. So 1 times anything is itself. So just add up these numbers. So take your calculator. What'd you get? 543. Is that what you guys got, guys? Mm-hmm. Perfect. Okay, that's my lower estimate. Lower estimate. Now let's do the upper estimate. I'm going to do RAM. 1 times what number? 70 plus 1 times plus 1 times plus 1 times. Perfect. Go ahead and multiply them. Or add them up, I guess.
758.
Somewhere between 543 gallons and 758 gallons of oil has leaked. Somewhere. Probably closer in the middle to those two numbers. Cool or not cool?
Very cool.
Cool. Let's continue. Now they want all of them after 8 hours. Relax. If you want to do a hack, you can just do 543 and then just continue from there. I'm going to show all the work, guys, because I think we're rookies right now. But if you know what's up, you can go ahead and just, Okay, so here it is. I'm going to say lowest, or let me change my color back to purple. Lower approximation. And I'm going to repeat everything on the top. 1 times 50 plus 1 times 70 plus 1 times 97 plus 1 times 136 plus 1 times 190 plus 1 times 265 plus 1 times 369 plus 1 times 516. Is that the last one if I'm doing lower? Yes. What do you get with that one?
1,693.
1,693 gallons. All right, engineer. Now do upper. What'd you guys get?
2,363.
2,363 gallons. Okay, how do we feel, guys? Okay, last one. Yeah, this is all based on context and what you believe, what is worst case, best case. The tanker continues to leak 720 gallons per hour after the first 8 hours. If the tanker originally contained 25,000 gallons of oil, approximately how many more hours will elapse in the worst case scenario, or worst case, before all of the oil has leaked? In the best case, what is worst case? Like the most oil has come out? And then, so it's not okay. And then the least case, the best case is when the least amount of oil has come out. Okay. So for the most amount of oil that's come out, then we have this one, right? So this is how much oil has come out. And then this is how much it comes out for the remaining, for the difference. So what you're going to do, take out, so you got 25,000 gallons of oil and subtract 2,363 gallons. So what is that? 22,000 what? 637 gallons. Okay. if I want to figure out how much more time, well, that's going to take the shortest time. Well, it doesn't matter because all 20, they want to know all of it, right? Okay, so how much time do I have left before all of it drains out if I already know that it's leaking at 720 gallons per hour? So here's how you do it, guys, in case you don't know. But you can just use dimensional analysis. Yeah, you guys already know. Take the 22,637 gallons, and then you're going to go divide it by 720 gallons per hour. See? And that's going to tell you how many hours it's going to take left. 22637. 2263. 31.440. That's how many hours. Damn, that's a lot of hours. 31.440 hours. So it's going to keep leaking. That's a lot, guys. 720 gallons an hour into the ocean. It's going to take a whole day. So I don't know if this is what you call worst case or best case, because it is how, like... Okay. All right. Now, assuming we're at the lower end, let's see how much time we're working with. So you're the engineer, right? So this is, what did you call this? This is worst case? Mm-hmm. So this one should be longer then. Take your 25,000 gallons, subtract 1693. What is that? 23307. 23,307 gallons. Okay, you take your 23,307 gallons, and you're going to divide it by 720 gallons per hour. 32.3708. So you don't have much time. Regardless of whether you're doing best case or worst case, look how close in time that is. So you're somewhere between 31 and 32 something hours. So if you're the engineer and you know that it's coming out at that rate after 8 hours, like, sir, you have about 30 hours before everything's out of here. So now you can see like how this is applicable. Cool or not cool?
Very cool.
All right. So if you have, I gotta.